Good morning. Good morning. I am Mr.CHRISTAL, ANAND, Assistant Professor of Department of Information Technology, Buildtech Multitech, Dr. Rangarajan, Dr. Sauntala Engineering College. Today, I am going to talk about software-defined networks. Introduction about software-defined networks. So, first topic is evolving network requirements. Software-defined networking is an evolving network architecture beheading the traditional network architecture, focusing its disadvantages in a limited perspective. A couple of decades before, programming and networking were viewed as different domains, which today, with the lights of SDN bridging themselves together. This is to overcome the existing challenges faced by the networking domain and an attempt to propose cost-efficient, effective, and feasible solutions. Changes to the existing network architecture are inevitable, considering the volume of connected devices and the data being held together. Software-defined network introduces a decoupled architecture and brings customization within the network, making it easy to configure, manage, and troubleshoot. So this is the different network architecture from a traditional network and the software-defined network. So, traditional network, so every node that is contain data plane and a control plane. So this traditional network combined hardware and software bundled together. But software-defined network, it is distributed. So the software and the hardware, it is separated. It is all the data plan is controlled by centralized controller, which is called control plane. So there are different problems in traditional network devices. The first one is they are vendor specific, and hardware and software is bundled together, and it is very costly, and new features can only be added at the will of the vendor. Devices are function specific, and if your network consists of hundreds of these devices, so each device has to be configured individually. That is one of the very big problem, which means a disadvantage. Innovations are very rare. Last 3 decades have not seen many innovations in networking. So avoiding these problems, there is a software-defined network. So software-defined network, there are different data plans which is controlled by the centralized controller. So there is a software-defined networking approach. Software-defined networking is an approach to network management that enables dynamic, programmatically efficient network configuration to improve network performance and monitoring. It is a new way of managing computer networks that makes them easier and more flexible to control. In traditional networks, the hardware like router and switches, hub, decide how data moves through the network, but software-defined network changes this by moving the decision making to a central software system. This is done by separating the control plan, which decide where traffic is sent, the control plan from the data plan, so which moves packet to the selected destinations. So control plan which is decide where traffic is sent, and a data plan which moves packet to the selected destination. So component of software defined networking. There are different components are available. SDN applications, SDN controller, SDN networking devices. So SDN applications relay request or networks through SDN controller using application programming interface. SDN controller collects network information from hardware and send this information to applications. SDN networking devices help in forwarding and data processing tasks. So why SDN is important? Better network connectivity, better deployment of applications, better security, better control with high speed. First one is better network connectivity. SDN provide very better network connectivity for sales, services, and internal communications. SDN also help in faster data sharing. Second one, better deployment of applications. Deployment of new applications, services, and many business models can be speed up using software-defined networking. Third one, better security. Software-defined network provide better visibility throughout the network. Better control with high speed. Software-defined networking provides better speed than other networking types of applying an open standard software-based controller. So next we will see advantages of SDN. The network is programmable and hence can easily be modified via the controller rather than individual switches. Switch hardware becomes cheaper since each switch only needs a data plan. Hardware is abstracted, hence applications can be written on top of the controller independent of the switch vendor. Provides better security. SDN provides better security since the controller can monitor traffic and deploy security policies. For example, if the controller detects suspicious activity in network traffic, it can reroute or drop the packets. Software-defined networking architecture. Software-defined networking architecture decouples the network control plan from its data plan. Centralized control through a software-based controller. So this allows a dynamic and a programmable network management, improving flexibility and efficiency compared to traditional network. Key components include the application layer, control layer, and infrastructure layer. So the three layers comes under the key components. Next, this is the architecture of software-defined networking. So this architecture of software-defined networking contains there is a three layers. Already we have seen application. We have seen application layer, control layer, and the infrastructure layer. So the first row says that it is a application layer. Then second, we can see there is a control layer. Then we can see infrastructure layer, which is included switches, everything. So application layer. This layer houses network application and services that define network behavior. Example include cloud management platform like OpenStack and other network management tools. So application interact with the control layer through northbound application programming interface. I will tell you what is northbound APIs. Then control layer. The SDN controller resides in this layer. It is the brain of the SDN architecture, making network control decisions. The controller communicates with the infrastructure layer using southbound APIs such as OpenFlow. The controller manages network resources, define policies, and optimize traffic flow. Infrastructure layer. This layer consists of physical or virtual network devices that forward data traffic. So physical or virtual network devices like switches or routers. These devices are controlled by SDN controller. So which programs they are forwarding tables. So the infrastructure layer is abstracted from applications, allowing for flexible and dynamic network management. So see next one, benefit of SDN. Increased flexibility and agility. SDN enable rapid network changes and deployments in response to evolving business needs. Improved network performance. SDN allows for optimized traffic flow and resource utilization. And reduce cost. SDN can lower operational costs through automation and centralized management. Simplified management. SDN simplifies network administration and troubleshooting. SDN data plane. In software-defined networking, the data plane is the part of the network responsible for forwarding data packets based on instructions received from the control plane. It consists of network devices like switches and routers that act as forwarding engines, executing the decisions made by the SDN controller. Essentially, The data plan focuses on the physical movement of data, while the control plan handles the logic and the intelligence behind the movement. SDN control plan. The SDN software definition networking control plan is the brain of a software defined networking architecture. It is responsible for making decisions about how network traffic should be forwarded, setting up network path, and managing the overall network behavior. It's typically implemented in a centralized controller, which separate it from the underlying network hardware. SDN application plan. So the SDN application plan is the layer within a software-defined networking architecture where network applications reside and interact with the SDN controller to manage network behavior. It's essentially the brain of the SDN, allowing for centralized control, programmability, and automation of network functions. This plan enables applications to dynamically adapt network behavior based on real-time conditions and user needs. So this is the architecture of application, control, and data plan. So here first there is a application plan and a control plan that is connected between northbound API then there is a control plan and a data plan. It is connected with the southbound API. So what is that? Northbound API act as the interface between the SDN controller and applications, allowing them to manage and configure the network. It provides an abstraction layer exposing network functionalities to applications through a programmable interfaces. So northbound API acts as the interface between the SDN controller and applications. You can see in the images. So southbound application programming interface is the interface used by the SDN controller to communicate with and manage network devices like switches and routers in the data plan. It essentially allows the controller to program the behavior of these devices, enabling centralized control and dynamic network management. Southbound API is the interface used by the SDN controller to communicate with manage network devices like switches and routers in the data plane. Thank you. If you have any query, you can contact me. Thank you.